Alright, so today we're going to be doing multiplication. First, we're just going to start with positive numbers. When you see multiplication and you see a problem like, let's do 3 times 7. Instead of looking at it as something complicated, like this little operation here looks a little bit intimidating. But what is really happening here is we're adding 3 7 times. So if we did 4 times 2, that's the same thing as 4 plus 4. So essentially, you are taking the first one and you're adding itself this amount of times. So this is a really awesome pattern when it comes to multiplication. It's really just addition, but you're adding the same number multiple times. And there's another idea that comes after this, and that is called exponents. So if we have something like 4 to the second power, this is the same thing as 4 times 4. So there's these really cool layers in algebra and so many patterns that you can find. So it helps to start looking at multiplication as addition, but multiple times. So you can do it this way, where you have 3 plus 3, that's 6, plus another 3 plus 3, plus another 3 plus 3 plus 3, and then I have 12 plus 9, which gives me 21. You can do it this way, and then we know 4 plus 4 is 8. So if you ever get stuck, this is a method that you can use anytime that you get stuck, right? The key concept of multiplication is that it is addition of the leftmost number that amount of times. And as long as you remember that concept, you'll be good, because you can always refer back to this method. So let's say we have 14 times 3, or we can also write it this way. This is the same thing as 14 plus 14 plus 14. And you can do it this way, or we can do it this is called long algorithm, I believe. People usually say algorithm when there's steps involved. In this case, there is steps, so we start with this first column right here, and we do 4 times 3. So what that looks like is 4 plus 4 plus 4, and we get 12. So we're just going to write the 12 down there in the first row. But since we have two numbers here, we're going to add a 0 here. And this is something, every time that you're adding a row, so like this is row 2, you're going to have 1 0. And the number of rows, the way you can tell how many rows you're going to have is how many digits you have up here. So up here, we have a 1 and a 4, we have 2 digits, so we're going to have 2 rows. So if we were to have like 142, we're going to have 3 rows. And depending on how many rows, like let's say we did have 142 times 3, we're going to add another 0. when we add the new row. So the first row is going to have 1 0, the second row is going to have 2 zeros. Let's say we have 4 digits. That's going to be 3 zeros in the fourth row. But right now we're only working with 2 digits. So we already did 4 times 3. Our next step is to do 3 times 1. We also forgot the 0 here. 3 times 1, or 3 times 10, is 30. And then what we do is we add these up. So we get 2 plus 0 is 2, and 1 plus 3 is 4. And that is our answer. So that is the long algorithm, or maybe it's just algorithm. I'm actually not entirely sure. But this is a very, like, I don't know, kind of step-by-step thing, and sometimes these get really crazy and they go very far down. But I think another fantastic method is called the area box method. So we have 14 times 3. And what happens is we break this up. So this is 10 and 4, and that's just 3. So we have 2 digits here, so we're going to make a box. Right here, I'm going to put my multiplication sign, and I'm going to put the tens right here, and that's about the only 10 I have. I also only have 3 on this side. That's going to go right here, and my 4 is going to go right here. And then we do 3 times 10, which is 30, and 3 times 4, which is 12. And then my second step is to add those numbers together, and we get 42. So the first number, we're essentially breaking it apart, and we're putting it in the top row. And then the second number, we would also break it apart, but in this case there's only 1 digit. That's going to go on this side. And then you would multiply through. 1 times any number is going to be that number, and 0 times any number is going to be 0. Alright, let's say we have a more complicated problem like 27 times 13. So first I'm going to break this up into 20 and 7. I can start making my area box model. So I have 2 spaces here, so I know I'm going to have 2 columns. I'm going to have 20 here and 7 here. That makes 10 and 3, which is 2 spaces, so I'm also going to have 2 rows. And then I multiply in every box, so first I'm going to do 10 times 20, and there's this cool trick where sometimes you can use the number of zeros to tell you how many zeros you're going to have in your answer. So here I have 2 zeros, and then 1 times 2 gives me 2. In cases where this changes, like the number of zeros, is if you have, let's do 50 times 40. I know I'm going to have 2 zeros, but 5 times 4 is actually 20, so it's bigger than 10. And when my number is bigger than 10, I'm actually going to have another 0 in there. So that's another cool pattern to find. When you're doing algebra, there's lots and lots of different patterns that you can find. And then we have 7 times 10, which is 70, and 20 times 30 is 60, and 7 times 3 is 21. And then what we do is we add all of these. So 270 plus 81, right? Because that gives me that, and that gives me 81. 1, and then 7 plus 8 is 15, but that's bigger than 10, so I'm going to add a 10 over here, and imagine there's like a 0 here. 1 plus 2 is 3, so 351 is my final answer. Alright, let's try this with a really big number. Let's say 123 times 45. So this is going to become 120 and 3. So when you're doing the area box method, you break it up into 100s, 10s, and 1s. This one is going to be 40 and 5. And the number of chunks that you get, or whatever you want to call it, you have 3 spaces. So this is going to tell me that I'm going to have 3 columns. And this is going to tell me, because I have 2 separate things, or 2, I don't know what you would call it, this is going to tell me how many rows I'm going to have. So I'm going to have 2 rows. So I'm going to have my multiplication sign there. And I'm going to have 3 columns. I'm going to have 100 here, I'm going to have 20 here, and I'm going to have 3 here. I'm also going to have 2 rows. And I'm going to have 40 here and 5 here. And then I'm going to multiply every box. So I'm going to do 40 times 100, which gives me 4,000. I used the number of zeros trick. We have 3 zeros here, and 1 times 4 is 4, which is less than 10, so I don't have to add an additional 0. I can just put the 4 there. And then 20 times 40 gives me 800. 3 times 40 gives me 120. And a little trick that I used there was I did 4 times 3, which gives me 12. And then since I have a 0 here, that's how I got 120. 5 times 100, well, I know 5 times 1 is 5, and then I use the little zeros trick. 5 times 20 is 100, and 5 times 3 is 15. Alright, so now that we have all of these things, or we have the boxes complete, let's add them all up. So we're going to have 4,920 plus 615. This is from this row here, and this is from this row. And now we're just adding them together, so 5 plus 0 is 5. 1 plus 2 is 3. And 9 plus 6 is 15. And since 15 is bigger than 10, we're going to add this 1 over here. and 1 plus 4 is 5. So then my final answer should be 5,535. So some patterns that you can find in multiplication, there's that zero trick that I was talking about, but also 5 times any numbers give me a number that's going to end in a 5 or a 0, and 2 times any number is going to give me an even number. Even numbers look like 2, 4, 6, 8, 10, 12, and so forth. Let's go to 20s, we're going to have 22, 24, 26, 28, 30. So they're always going to have these numbers in them. Try and see if you can spot any other patterns when it comes to multiplying numbers. Alright, so multiplying positive and negative numbers. If I'm multiplying let's say this is a positive number times let's say this is a negative number, I'm going to get a negative number. And as we know, if we do positive times positive, that gives me a positive number. And if I do a negative number times a negative number, that's going to also give me a positive number. And I really wish I could tell you why, but I haven't gotten into that yet. Maybe I'll do a proof on it sometime in the future. But I will say that the reason this one happens is, let's say I have 4 times negative 2, which is also the same as negative 2 times 4, because we can switch them around in this case, which is the same thing as negative 2 plus negative 2 plus negative 2 plus negative 2. Maybe this one over here, a negative times a negative, would be, like, let's do negative 2 times negative 4. Maybe it's subtraction, so it's negative 2 minus negative 2 minus negative 2. I don't know. I would maybe test it out and see what happens, right? All right. But here, it turns into, negative 2 minus 2 minus 2 minus 2. So we keep getting smaller and smaller, not smaller, but more negative, right? So when we have a positive number times a negative number, we're going to get a negative number as our answer. And when we have a negative number times a negative number, we're going to have a positive number as our answer. So let's do negative 7 times 3. This is the same thing as negative 7 plus negative 7 plus negative 7. Sometimes the first thing I do is, okay, I see a negative number times a negative number. Or no, this is a positive number. So I know I'm going to have a negative answer. So I'm going to put that negative sign there right away so I don't forget, right? Because then what I can do is, if my negative sign is here right away and I don't have to worry about it anymore, I can just do 7 times 3, which is 21. And boom, my answer is going to be negative 21. All right, let's do negative 7 times negative 2. So a negative times a negative is going to give me a positive. So in this case, I can just do 7 times 2, which is 14. And since a negative times a negative gives me a positive, I'm going to have a positive answer. When you come across a problem like negative 237 times 5, right? You can make the area box method and go about it as normal. However, since you have a negative times a positive, and since you have a negative times a positive, you know you're going to have a negative answer, so just put the negative sign there right away. And then you can go about regular steps here. And you would add them all up and you would get some number. But since it's a negative times a positive, you're going to have a negative answer. What would this be? This would just be 0. All right. What is this one? So we have a negative times a negative, which is going to give me a positive number. So we can just do 4 times 2. We're going to have 8. Alright, and then just to get you familiar with some notation, I should have brought this up earlier, but sometimes multiplication is also seen as a little dot. So this is the same thing as 7 times 2. But you can also just put them next to each other in parentheses. So like I can have this 7 on the outside times 2 in parentheses. These are all the same thing. I can also have something that looks like negative 7 times negative 2, which would give me positive 14 because we have a negative times a negative. I can also have something like this. What is going on here? There's no number here. But there actually is. There's a secret 1 there. So we actually have negative 1 times negative 2, which gives me a positive answer of 2. I can also just have this, which is the same thing as negative 1 times 2. And when I have a positive times a negative, what's that going to give me? I'm going to have negative 2. Alright, so here are some practice problems for you guys to do. In these practice problems, I use a dot to indicate multiplication. So this is the same thing as 16 times negative 2, and it's the same for all of them. Just different notation is all. And I'll put the answers up at the end of the video.